10, 9, 8, 7, 6, 5, 4. We've gone for main engine start. We have America's first space shuttle.
The first space flight of NASA's Space Shuttle fleet was the beginning of a new era in space travel. Hi, I'm Marty.
And I'm Beth.
Today, we are cartoons.
Because of the pandemic, we aren't in the museum today, so we sent our avatars instead. In this episode, you will see some footage that we filmed before March of 2020.
You know what the best part of being a cartoon is?
What?
We can float, just like astronauts.
The space shuttles were reusable vehicles that launched like a rocket, landed like a glider, deployed satellites, and helped build the International Space Station.
It looked and operated very differently from anything that came before it, and provided new opportunities for research and a workplace in microgravity.
Today, we'll be learning about the legacy of the Space Shuttle program. This is STEM in 30.
Hey, that Newton guy really knew what he was talking about. Here at the Smithsonian's National Air and Space Museum Stephen F. Udvar-Hazy Center, we have our very own Space Shuttle Discovery. Discovery made the most flights and traveled further than any of the other orbiters. It flew 39 missions and spent a total of 365 days in space. One of its main contributions was launching and servicing the Hubble Space Telescope. Retiring in 2011, it was the oldest and most accomplished orbiter.
1. Booster ignition and the final liftoff of Discovery.
Discovery means finding or uncovering of something.
I'm joined by Dr. Michael Barrett, who is a NASA astronaut, and you were on Discovery, and you have a great story about the name.
All of our shuttle fleet were named after great ships of exploration, and Discovery is important to me for a couple of reasons. Number one, I flew aboard the last mission of Discovery. It was an incredible honor. But also, many great ships of exploration had that name, Discovery. The first we know of was a 1604 Henry Hudson ship that was used to discover the waterways in the north of Canada. Captain Cook's second voyage of exploration had a ship, Discovery, in it. Captain George Vancouver's ship, which explored the North Pacific, and Robert Falcon Scott's ship that explored the Antarctic, built to purpose, built for Discovery, was also named, in fact, Discovery, and several other ships beyond that. I'm more excited than anything to see what other ship, what next ship will be called Discovery, and where will it go?
The names are important.
Names are important.
As Michael Barrett said, just like Discovery, the entire shuttle fleet was named after famous ships of exploration, and their names alone carry meaningful definitions.
Enterprise is a project or undertaking, typically one that is difficult or requires effort. While NASA had originally chosen Constitution to be the name of the first shuttle, fans of the TV show Star Trek successfully campaigned for the new shuttle to share the name of the popular exploration vessel in the show, the USS Enterprise.
Star Trek fans can be very persuasive.
Built without engines or a functioning heat shield, it was never outfitted for spaceflight. Instead, it conducted tests in the atmosphere from a Boeing 747.
And liftoff of Columbia.
The word Columbia is derived from Christopher Columbus. Columbia was named after the ship that explored the Columbia River and shared the name with another famous NASA vehicle, the command module of Apollo 11. Columbia was responsible for the first launch of Spacelab and the deployment of the Chandra X-ray Observatory.
And liftoff of the orbiter Challenger.
Challenger is someone who discerns the truth or tests the abilities of something. Named after a British ship famous for a scientific expedition that laid the foundation for oceanography, Challenger shares its name with the Apollo 17 lunar module. Challenger was more lightweight than Columbia and boasts both the first spacewalk from a shuttle and the first untethered spaceflight.
Liftoff of Space Shuttle Atlantis.
Atlantis is a mythical island of Atlas said to be in the Atlantic Ocean. Atlantis was named after a research vessel that was the first to use electronic sounding devices to map the ocean floor. Its mission to the Russian space station Mir included the first on-orbit U.S. crew exchange, which would later be a common occurrence on the International Space Station. Atlantis flew the final mission of the Space Shuttle program.
Spreads its wings one final time.
Both of your schools chose the name Endeavor, which Webster's defines as to make an effort, strive, to try to reach, or achieve.
Named after Captain James Cook's first research vessel, Endeavour was the first shuttle to use a drag-chute landing system. Endeavour was also the first shuttle to launch U.S. modules to the International Space Station.
Living up to their namesakes, the Space Shuttle fleet symbolized the peak of human exploration, opening up space to more people than ever before and introducing new opportunities for science and research.
Okay.
During the Apollo program, astronauts traveled to the moon, and one of the things that became very clear at the distance of the moon was that the Earth was beautiful, that we wanted to study it more, and that we wanted to be around it for a very long time. To do that, we needed vehicles to be able to let us stay in Earth orbit for longer periods of time. And so the Space Shuttle facilitated that ability. It's where we learned how to stay in space longer, study the effects of microgravity on different aspects of science, and also look at how we could live in space on a more permanent basis.
I was watching the Apollo program go on, these rockets lifting off and just going into the sky and just completely disappearing. At that moment where I watched the Apollo 11 crew land, and I asked about, should I become an astronaut? The next question that came out of my mouth was, can somebody black actually be an astronaut? This was just after the Civil Rights Act had just been passed, and so segregation had not departed from our society.
Throughout the 1960s and into the 1970s, NASA selected astronauts based on their qualifications, but those qualifications included being a man, being a test pilot, and later being a scientist. The space shuttles would have larger crews doing more diverse activities, and they needed people with that kind of experience on board the space shuttle. And so, with the selection of the class of 1978, people with different kinds of scientific backgrounds, women, people of color, began being chosen for space shuttle missions.
I wanted to be an astronaut, but as I got older, it looked like that was not going to happen. And then all of a sudden that opportunity presented itself, and I was in the right place with the right credentials.
Sally was finishing her PhD in physics at Stanford University when she read in a student newspaper that NASA was looking for new astronauts. And for the first time, women could apply.
It was all I needed to know. That barrier is down. It's now up to me. If I don't become an astronaut, it's because of me and not because of any social barrier. And I was simply off and running.
The design of the space shuttle allowed for a much larger crew than on any previous spacecraft. That included a commander for the mission, a pilot for the space shuttle, and then any number of mission specialists and payload specialists who would actually be involved in the mission of the flight itself. Mission specialists who operated the Canadarm inside the payload bay, scientists who would conduct experiments inside Space Lab, and also payload specialists who were able to participate on behalf of the companies who sponsored their space flights.
So I had a degree in medicine and a minor kind of in chemistry. So when NASA came along and selected people to be mission specialists, that was what they were looking for. People that had a major area, but also knew something about another area of science.
The space shuttle and its design were dramatically different from everything that had come before. It was larger, it could carry payloads inside a large bay. The shuttle could be used to deploy satellites, research equipment. Astronauts could do spacewalks outside in the payload bay, and they could stay in space for up to 2 weeks in Earth orbit.
With the introduction of mission specialists during the shuttle program, scientists were able to conduct research on the effects of microgravity on plants, animals, and even the human body. Through this research, we've found that one of the greatest challenges in keeping astronauts healthy is preventing bone loss. Preventing loss of bone density and microgravity will continue to be a challenge for astronauts in the future as they spend longer durations in space.
Hi, I'm Chloe, and I want to see how a loss of density affects our bones. We know astronauts can lose bone density because they don't have the pull of gravity putting stress on their bodies. For this, I have some Corn Puff cereal and plastic snack bags. Smaller bags make this easier. First, I'm going to fill up this bag and count how many pieces of cereal it takes to fill it up. I'm going to label this bag as a 0% bone loss, like a normal bone. Next, I'm going to calculate 60% of that total and put that many pieces of cereal into the second bag. This represents a 40% bone loss. Finally, I'm going to calculate 40% of the original bag and put that many pieces of cereal in. I'll label this bag as a 60% bone loss. Be sure the bag seals completely or you will have a mess. Now, it's time to see what happens to these bones when they are exposed to a sudden force. For this, we are going to put a big book on top and apply a sudden force. I'm going to repeat this for each bag. To calculate this, I divide the number of affected pieces in each bag, divided by the original number in the bag, and multiply by 100. That will give me the percentage of the bone that was affected. You can see that the more bone loss, the more bone is affected by a sudden jolt. That's why exercise is so important on long space flights. Bone density loss can have serious effects on astronauts when they are reintroduced to Earth's gravity.
On the shuttle, to prevent bone density loss, astronauts used resistance bikes and other specially made exercise equipment. But astronauts didn't have a designated area to work out like we often do here on Earth. They had to use the same space to exercise, eat, sleep, and carry out their mission.
The body of a space shuttle orbiter is about the size of a small jet airliner. But only part of that was livable for the astronauts. Marty got to visit the National Museum of the United States Air Force in Dayton, Ohio, where one of the shuttle crew trainers is located. And we both got to check out the fuselage trainer at the Museum of Flight in Seattle. It wasn't until we were standing inside that we realized there's not as much room as you think.
What we're looking at right behind me here is what we call the CCT, or the Crew Compartment Trainer. It's what all space shuttle astronauts used to train in before their space missions.
Why is training like this so important for an astronaut?
Well, it's important mostly because you don't get the chance to do anything over. Time is crucial, schedules are tight, equipment is expensive, and so it's really important to get it right the first time.
The orbiter can easily be divided into three main sections: the forward fuselage, the mid fuselage, and the aft fuselage. In the forward fuselage is the flight deck. Here the commander and pilot control the flight maneuvers of the vehicle. Directly behind these controls is the aft flight deck. This is where mission specialists execute maneuvers for rendezvous and docking. Windows into the payload bay are used to monitor satellite deployment and retrieval. Both stations are within arm's reach of each other, just a few feet apart.
How accurate of a recreation is this to the actual space shuttle?
It's exactly like a space shuttle in terms of where the instruments are located and how some things work and so on, but in other ways it's not. The instruments don't actually have an effect on anything. The vehicle doesn't go anywhere, and the outside of it is made of plywood.
How many hours would an astronaut spend training in a simulator like this before they went into space?
Oh, they'd spend 400 to 500 hours in the CCT. Some astronauts estimated that for every hour of mission time, they would spend 10 hours in training. And it's really, for such a big vehicle, the living space in a space shuttle is actually pretty small.
Directly beneath the flight deck is the middeck. Stowage lockers are used to store the flight crew's personal gear, equipment, and experiments. The aft fuselage contains the vehicle's engines and maneuvering systems. The mid fuselage contains the payload bay, a massive space located in the center of the shuttle used to transport things to and from space. These doors are 60 feet long. That's as long as a bowling lane. Because they open while in orbit, this section was separated from the crew quarters. I'm joined by NASA astronaut Paul Richards. You actually flew on Discovery. Do you want
Yes.
to tell us a little bit about that flight?
Sure. It was STS-102. We delivered 12,000 pounds of gear in the first Italian module, Leonardo, and brought 9,000 pounds of gear home.
Some of the payloads the shuttles deployed have changed the way we view our solar system, like the Magellan probe, launched from Space Shuttle Atlantis to investigate other planets. But none has quite captured humans' curiosity and changed our understanding of the universe more than the Hubble Space Telescope.
I got to fly in space aboard the Space Shuttle Atlantis. We launched into space to catch up with the Hubble Space Telescope. I used the robotic arm to reach out and grab it and put it in the back of our shuttle's payload bay so we could do some repair work.
The Hubble Space Telescope is probably the most significant scientific instrument ever created by humans. It's taken over 1.4 million images for tens of thousands of scientists around the world. But the other thing Hubble has done is show us for the very first time really how beautiful and amazing the universe is.
The pictures that I love are the ones that we call the deep field. An astronomer had the idea of looking at a dark patch of sky, and they looked at that same dark patch of sky for a long time and realized after compiling all the data that there are hundreds of thousands of galaxies just in this one segment of sky that looked empty to us.
Hubble was the first telescope designed to be visited in space by astronauts to perform repairs, replace parts, and update its technology with new instruments. Between 1993 and 2009, there were 5 servicing missions to Hubble.
The whole point of going to the Hubble and putting in new instruments is to improve its capability. So when we put a new instrument in and the pictures come back, they're sharper and have more detail than anything ever seen before.
The object behind me is one of the cameras that used to be on the Hubble Space Telescope. The curved white part on the outside was open to space, and lots of little tiny meteorites hit it. So when the astronauts went to fix Hubble, they took the camera, brought it back to Earth. The holes that you see are where the scientists took out those pieces so they could study the little meteorites.
In 2009, the Space Shuttle did the final servicing mission to the Hubble Space Telescope, and it's lasted now over 10 years, and it's still in great shape. In the meantime, we're building the James Webb Space Telescope. It's an infrared telescope, and so it can see deep into places where baby stars are forming, farther back in the universe, and study the planets and moons in our own solar system in detail we've never seen before.
Hubble and James Webb let us look at space in different ways, like the Spartan spacecraft, which used ultraviolet light to look into the galaxy. NASA planned to document Halley's Comet in January of 1986 using a Spartan spacecraft, but the mission was lost when Challenger exploded shortly after launch. Along with deploying the Spartan spacecraft and a relay satellite, this mission planned to carry out several lesson plans as part of the Teacher in Space program. 17 years later, a second shuttle, Columbia, was lost during re-entry. This mission included microgravity research conducted in the first Spacehab module, along with experiments to prepare for extended stays aboard a space station. These tragedies came with lessons to be learned and had a profound impact on the Space Shuttle program. Both after the loss of Challenger and Columbia, shuttles returned to flight with improved safety and precautions. Both shuttles have enduring accomplishments. Columbia was the first reusable space vehicle to ever take flight, and Challenger carried the first American woman, African American, Dutchman, and Canadian into space. Another lasting legacy of Challenger is the Teacher in Space program.
Well, we're here today to announce the first private citizen passenger in the history of spaceflight. This passenger would be one of America's finest, a teacher. The teacher who will be going into space, Krista McAuliffe. Is that you?
Barbara Morgan was chosen as Krista McAuliffe's backup in 1986. She went on to fly on STS-118 in October of 2007, and I got a chance to attend that launch. As a teacher, seeing another teacher launch into space literally brought tears to my eyes, and feeling the power of the space shuttle from over 2 miles away was an experience I will never forget. After the Challenger tragedy, NASA replaced teachers in space with educator astronauts, Instead of recruiting private citizens to fly, they trained mission specialists that had education backgrounds to be astronauts. In 2004, NASA selected Ricky Arnold, Dottie Metcalf-Lindenberger, and Joe Acaba.
I arrived at NASA with people who had spent their entire life preparing for this, test pilots and aerospace engineers. It was really intimidating, and I had to learn everything new. I didn't even understand the vocabulary.
When I got to fly on the Space Shuttle, I did some of the hardest training of my life. I would go in on my weekends and practice in the simulator. I even built a cardboard simulator at home so that I could think about where all those switches were and where I needed to focus at different points in flight.
There's no more important profession than teaching. I mean, it's the most important job out there. It's just something that kind of called me. I was drawn to it, and once I started, I knew that was the job that I really wanted to have and I was meant to have.
Education continues to be an important aspect of human spaceflight.
And what was really important for me that we were able to accomplish, we were able to finish some of the lessons that were going to be delivered by the crew of Challengers. So to have the opportunity to complete a small part of that magnificent mission was really a really meaningful part of the year of education on station.
If you talk to any kid, they love space and they love exploring. That's what they do every day. So it's a very kind of an easy topic to talk to kids about, but it's an important one that we can use to help inspire them to kind of follow their dream, whatever it may be.
To me, education is very important because we're curious people. My education is ongoing. Every day I learn something.
The generation that we're getting ready to hand off stewardship to this planet, I just see a refreshing commitment to service, cooperation, and understanding, and that really inspires me greatly.
Back when I was a middle school science teacher, I applied to be a part of the Educator Astronaut Corps. Even though I wasn't chosen, I still use space as a resource. I used my experiences to get kids excited about science and learning. I was selected to participate in a microgravity flight where I got to experience a few seconds of weightlessness. And let me tell you, floating is pretty cool.
Zero-G flights are just one way we can learn about microgravity without leaving the atmosphere. It can be really tricky predicting how your body is going to operate when floating in space. On 4 separate missions, astronauts who flew on the Space Shuttle Discovery conducted multiple science experiments demonstrating how different toys and sports activities perform in orbit. We want you to consider how playing everyday games like soccer, spinning tops, or even jumping rope might be affected by a lack of gravity, and what adjustments are needed as a result. Here are some ways that you can test out your guesses and try this at home.
I'm Ninette, and I want to know how playing soccer in space is different than on Earth. The rules of the games are you can kick the ball with your feet or bounce it off your head, but you can't use your hands to pass the ball. How does playing soccer change when played in space? In space, there is no gravity to hold the soccer player's feet to the ground. This makes it much harder to kick the ball with force in any direction since there is no surface to push against with your legs. So crew members must use their arms to help position their bodies in order to execute their move.
I'm Chloe, and I want to know how a spinning top operates in space. First, let's see how it works on Earth. To spin a top into motion, force must be applied in order to convert it from potential stored energy to kinetic moving energy. The momentum from the applied force keeps it spinning on an invisible axis until the top is slowed by friction from the table surface. Torque produced by gravity from the atmosphere makes it unstable, slowing it to a stop. Now let's see how it works in space. On the shuttle, the spinning top floats in microgravity. Because the top does not rotate on a surface, there is reduced friction. This allows the top to spin longer, with more stability.
The Toys in Space experiments are a great way to learn how the work done on the shuttle program relates to life on Earth. But it's not all fun and games. NASA is renowned for their groundbreaking achievements in technological advancement. Scientific concepts initially created for the shuttle program have been simplified and incorporated into our daily lives. You might recognize these motion simulators from the museum. They first started out as hyper-realistic flight training modules for astronauts and jet pilots, complete with hydraulics, a projection system, and a sound system to really feel like you're flying. Tire pressure sensors found in our cars were originally used to ensure the tires on the space shuttles were fully inflated and safe for landing. Light technology, once used for plant growth experiments on shuttle missions, evolved into the HEALS device. Today, this method is used to reduce patients' side effects caused by chemotherapy and radiation treatment from bone marrow and stem cell transplants. Just as the legacy of the shuttle program lives on in its scientific advancements here on Earth, it also ushered in the new generation of space exploration we're familiar with today.
Having fired the imagination of a generation, a ship like no other, its place in history secured, the Space Shuttle pulls into port for the last time.
The crew exploration vehicle will be capable of ferrying astronauts and scientists to the space station after the shuttle is retired.
After the International Space Station was built and the shuttle program retired, there was still a lot of work to be done in space. In need of new human transportation systems, NASA employed Russian Soyuz capsules and rockets to travel to and from the International Space Station. In 2011, NASA began a commercial spaceflight program to aid American companies in developing their own space vehicles.
The contracts we're announcing today are designed to complete the NASA certification for human space transportation systems capable of carrying people into orbit. Once certification is complete, NASA plans to use these systems to ferry astronauts to the International Space Station and return them safely to Earth.
With commercial spaceflight companies focusing on International Space Station transportation, NASA has been developing a new Space Launch System rocket and a new capsule able to go farther than the shuttle and commercial space flights are capable of.
Orion is the next generation of human spaceflight vehicle. It's intended to allow us to take the crews out into deep space and do exploration in the Earth-Moon region, and then on beyond when accompanied by other elements.
The Artemis program will use Orion capsules to send the first women and the next men to the Moon and to the future lunar space station, the Gateway.
We're going to go with international partners. We are going to lead a coalition of nations in a sustainable return to the Moon.
The Gateway will support regular lunar travel while also serving as a staging area for other deep space travel.
The legacy of the Space Shuttle program has a long-reaching impact on the future of space travel. And the great thing is, you don't have to be a rocket scientist to be able to see and learn from the shuttles.
While we welcome you to visit us here in Chantilly, Virginia to see Space Shuttle Discovery, there are Space Shuttle orbiters, shuttle trainers, and shuttle mock-ups across the country.
The shuttle was the first American vehicle to open space up to scientists and to international astronauts.
It connected the public to human spaceflight in ways we had never done before and helped build the International Space Station.
Even though the shuttle program has retired, it has irreversibly changed human spaceflight. Pilots, scientists, teachers, physicians, engineers, and many others all play a massive role in the exploration of space.
How will you play a part in future enterprises, endeavors, and discoveries?
And if you enjoyed this video, be sure to follow STEM in 30 on Facebook and Twitter, and subscribe to the National Air and Space Museum's YouTube channel.
Thanks for watching.
The Space Shuttle Discovery is the champion of the fleet, as some have described her. She has the most hours in space. She flew the most missions of the remaining space shuttles and flew the most diverse types of missions. And millions of miles flown in space is really a testament to the entire community at NASA who really wanted to have us have this capability and be able to do it safely.